In this video, we're covering the substitution method. So before we begin, we'll look at some terminology. So the substitution method is a method of solving simultaneous equations that involve substituting one equation into another. So what that means is we substitute the x or the y variables from one equation into the other. Now, it's not always x and y, sometimes it's different letters, but it's the same principle. So on your screen in red, you can see y equals 2x and y equals x plus 4. What we would do here is, because we both have something y equaling something, we can swap the y in one of those equations to what it equals in the other. So if I'm saying here y equals 2x, I can say that this y here also has to equal 2x. So what that means is I actually end up with 2x here, because I'm changing that y to 2x equals x plus 4. And because now we only have x's, we can actually solve that and find what x equals, and then go back and find what y equals after. Now sometimes it doesn't involve making the x or the y the subject of the equation using inverse operations, so be aware of that and know your equation and algebra skills well. So to begin, we'll look at one example here. We have x equals 3 plus 2y and x equals 9 take away 7. Now that 7 was definitely not meant to be there, and it's meant to be y. Alright, so this is what we call, this is a nice simultaneous equation because we have x equals and x equals. There's no rearranging that we need to do. All we need to do is say that this x over here is going to equal whatever our x over here is. Alright, so what we do is we change that x here, in the one I circled, to 3 plus 2y equals, and it just equals what it still equals, so 9 take away y. Now at this stage we need to rearrange it and use inverse operations to solve it. So the first thing I want to do is bring all the numbers over to the right side. So I'm going to take away 3 from both sides. That cancels that out. I'm left with 2y equals 6 take away y. I then want to bring all the letters to the left, so I want to plus this y. That cancels that out. I end up with 3y equals 6. And then remember that 3y is really 3 times y. So what I want to do there is divide by 3. And I'm left with y equals 2. Alright? But we're not done. At this point, we know what the y is. We need to go back and find what the x equals. So I'm going to draw a dotted line down here to show we've got some working space on the right. So I'm going to pick one of those original equations. Now I'm just going to pick the x equals 9 take away y because it means I don't need to do any multiplication. So x equals 9 take away y. We said y was 2, so I can change that back up here to 9 take away 2. So x equals 7. So we know that y equals 2 and x equals 7, and that's the solution to these simultaneous equations. So we'll look at a different one now. So this time we have y equals 2x plus 3 and 3x minus y equals 6. It's not as neat as it was before. It's still not too bad. It just looks a little different. So what we need to know here is that we have the y here, and we can change that to what the y over here was. So wherever the y is in that circle, I'm going to change it to 2x plus 3. So we get 3x, take away, and now because there's multiple terms here, I want to add a bracket. And this equals 6. Now, you'll notice that we have this part here. We need to expand this out because that minus does influence what's in the brackets. Now, if you remember, anything that's been multiplied by the negative changes signs. So what we get is 3x. The 2x was a positive number, so now it's a negative, so minus 2x. The 3 was also a positive number, so now it's a minus. The other way to do this, if you don't remember that little trick, is to multiply both of those, the 2x and the 3, by negative 1, and you'll get your answer. Alright, so now that we've done this, we can add our like terms. We've got some x's here that we should deal with, so 3x take away 2x is x, the minus 3 is still there, equals 6. Now we want to solve it for x, so let's get rid of this 3, so plus 3 to both sides, and we get x equals 9. That's great, we've got that, but we need to go back and find our y answer. So I'm going to draw a dotted line here. Now of this one, there's obviously one equation that's way better to use than the other. Now I want to use the y equals 2x plus 3 because it's going to tell me what the y is. I don't have to do any rearranging. So y equals 2 times 9 plus 3. So y equals 21. So we have x equals 9 and y equals 21. And we'll do one more. So we've got a nice neat one again. We've got x equals 2y and x equals 6 minus y. Because we have the x by itself here, we can substitute the 2y in. So we get 2y equals 6 minus y. Let's bring that y over to the same side as everyone else. We get 3y equals 6. We can divide by that 3. And we get y equals 2. Draw a dotted line down the middle. Now you don't have to do this. You can keep working down the page. This is just so you can see what's going on in the video. So I'm going to obviously pick the one on the left, the x plus 2y. Both of these are pretty much the same, so it doesn't matter. Now x equals 2 times 2, which is 4. Now you may wonder, does it matter which one I pick? So we just use the one on the left. What happens if I use the one on the right? I get 6 take away y, so 6 take away 2, and it equals 4. So it doesn't really matter which equation you use. You pick the one that you think is going to be easiest to solve and the quickest. So to end the video, we're going to do a quick recap. Now remember, with the substitution method, you're substituting x or y variables from one equation into the other. Now remember, you do sometimes need to do some manipulation using inverse operations to make the x or y the subject of the equation. Now remember, on your screen you can see the example. We had y equals 2x and y equals x plus 3. We needed to change the y in one of these. It doesn't matter which one because you end up with the same. But in this case, I changed the y in the right-hand side to 2x. So I had 2x plus x plus 3. And that gave me one variable which I can solve and then substitute back in to find the y value.